So today I will continue earlier lecture. Uh, Basically, the earlier lecture is the vector product. We have to start from the vector product to area and the volume calculation. So let us have a look at the earlier lecture briefly, and then yeah. So here I talked about dot product in the earlier lecture, and then after dot product I try to calculate the area of a parallelogram. That's what I did. So suppose now there are say it's a two-dimensional space. I'm taking an example from the two-dimensional space. So here if R1 and R2 two position vectors, and say this is R1 vector and it is represented by x and y, and there is incremental change in the value of x and incremental change in the value of y, then this new position R2 is represented by this is basically say x plus delta x, and it is represented by y plus delta y. So that means what is x? X is this distance which I have taken, and if I draw a perpendicular from here to here, this is also x plus delta x. This is represented by like this. Similarly, if I draw a perpendicular over the y-axis from here, then this distance is basically y, and if I draw a perpendicular from this point, means whose position is represented by R2, then this distance is known as pi plus delta y. So now if I try to find out the area, so that means this vector, this is one vector and this is another vector. So that means this vector is represented by delta x I cap, and this another vector is represented by delta y j cap. Delta y j cap. Then the area, this small area, this rectangular area is represented by delta x I cap dot delta y j cap, and say this area is represented by dA vector. So we have to take the cross product of these two. So it is represented by delta x and delta y, and what is I cross j? I cross j is represented by k cap. So it is represented by k cap is the it is pointing in this direction. And if delta x approaches to 0 and delta y approaches to 0, in that case this dA vector is represented by dx and dy k cap, and the magnitude of this vector is dA, sorry, here it is delta a it is delta a. Now it is represented by dx and dy. Its magnitude is basically dx and the dy, and it is pointing along the z-axis. This is a way that how this area can be calculated. So let us have a look at this, how this is comes out to be. As I told you earlier that if I cross j, these two are lying in the xy plane, then their pointing vector is along the plane perpendicular to both I and j. Similarly, j cross k is equal to I cap, and I cross ij jk, and the k cross I is equal to j cap, right? So let us have a look at that how this thing can be remembered. Say it is I cap is along this direction, this is j cap, and say this is k cap. So that means I am moving in the right-handed coordinate system, left-handed coordinate system. So if I is moving towards j in the counterclockwise direction, or j is moving towards k along the counterclockwise direction, and k is along this, if it is moving counterclockwise, then I cross j is k, and the j cross k comes out to be I, and k cross I gives us the j vector. But if we are moving in the clockwise direction, say for example, for example, it is I, it is j, and say it is k cap. So if j is towards I, then it is in the clockwise direction, or I along k, it is in the clockwise direction, or k to j, it is in the opposite direction. If I try to look at it, say it is j cross I, say it is in the clockwise direction, and it is opposite to this. Its order is opposite to this. I cross j is here, and here it is. So it is in the negative of this direction. Then it is minus k. Similarly, j to I or I to k, it keeps me minus j vector, means just have a look at these two parameters. Then I to k and k to j, it is always comes out to be k to j is minus I cap. So these are the few things which we have to remember when we have to take care consider the cross product. And about these things I talked about earlier, that how cross product can be, how the area of a parallelogram can be calculated using this. Say here. And let us try to find out cross product in terms of the Cartesian coordinates. So this is a way that how area can be calculated. So let us try to calculate cross product. In terms of Cartesian coordinate. Just a brief recapitulation of it. I am not going to talk about it in more detail. So say if a vector is represented by axi cap plus ayj cap plus azk cap, and similarly b vector represented by bxi cap, byj cap plus bzk cap, then a cross b is given as, it is represented in terms of a determinant. I'm just writing its way that how it can be written. I'm not deriving it. I, j and k, these are the unit vectors which we have to write down, and this is the x component of a, this is the y component, it is the z component, similarly bx, by and bz, and this determinant is basically represents the a cross b. And how it can be simplified? So it is first row, we have to write down it, and then excluding first row in the first column, we are remaining with the ay, by, az and bz. It is the 1-1 position, so it is even position, and it is the 1-2 position, 2-1 position, second row first column, first or second column, so it is 1 2 position, it is a odd position, that's why it is J. And excluding this, we can write down it's a AX BY and AZ BZ plus for this, because this is also even position, means first row and the third column 1 plus 3 is 4, so that's why it is positive sign here. So it is represented by AX AY BX BY. And how this can be solved? This is multiplied by with it and this is with this, and then taking difference of these two, so it can be written as AY BZ minus BY AZ into I cap minus J into, it is AX BZ minus BY AZ plus K cap, it is AX BY minus BX AY. This is a way that how this can be written. So it is AY BZ minus BY AZ I cap, and if I take a plus sign here, then these are also interchanged, this goes to here and this goes towards here, so I can write down it as BY AZ minus AX, okay, it is BX, sorry, it is BX, so it is yeah, it is BX, so it is BX AZ minus AX BZ plus K cap AX BY minus BX AY. This is a way that how the cross product can be calculated. Now let us have a look at or briefly talk about sorry, let me talk about briefly now what is scalar triple product. And what this tells us. So for the scalar product, say we are having 3 vectors A, B and the C. So say one vector is this say B vector and another vector is C vector, and these two vectors will form a parallelogram. This is B and this is C, so these both the vectors will form a parallelogram, and the area of this parallelogram is represented by like this. So this area of parallelogram is given by cross product of B cross C. Now let us do one thing. There is another vector with me, and so let us say that vector is the A, and yeah, this vector is A. So if I draw a perpendicular from here to here over this xy plane, then what is it? It is A cos theta, because if it is making an angle theta with this, with the plane, if it is making an angle theta, then this perpendicular distance of this plane is represented by A cos theta. Means this is the height of the parallelepiped. That means now it will become a parallelepiped. Let me finish that diagram also. So it's here and say this is like this, let me finish it. Yeah, so this is a parallelepiped which is there formed, and say h is the height of it, and this height of this is represented by a cos theta. So what is this? Or in other words, I can say that, say if I draw a perpendicular here, say it is the z-axis for example, or any axis, or it is a normal perpendicular to B and C, means this is the normal perpendicular to B and C, and say this is making an angle theta with this. Let me erase it. Yeah, so it is making an angle theta with this. Then this height is represented by this h. This is the height. This is basically a cos theta, right, as we have seen in case of dot product. So this is the height h. So that means when area of a parallelogram multiplied by height, this height, then it will become area, then it will become volume of parallelepiped. So in other words, I can say that the volume of parallelepiped is equal to the area of parallelogram containing B and C, and this is multiplied by corresponding height between two parallel faces. These are the two parallel faces, the perpendicular distance between them, and this perpendicular distance between them is nothing but it is a cos of theta. And what is theta? Theta is angle between, what is theta? Theta is angle between, rather than this, let me write down it as, yeah, it is a cos theta. Or rather than this, yeah, do one thing, it's more important, it's much better. So it is basically a cos theta multiplied by B cross C, its magnitude. Or in other words, I can say that this is A vector dot B cross C, its magnitude, and it is making an angle theta n cap. This is n cap, right? N cap kya hai? N cap is the normal to the plane containing containing B and C. B and C, right? So in other words, I can say that A dot B cross C, it is known as the scalar triple product. It is known as the scalar triple product, and it is nothing but it is volume of volume of parallelepiped. And it is the formula for this, and this is basically a scalar quantity. So that means volume is represented by the scalar triple product and area is represented by, so let me summarize the results. Vector or cross product, they tells us about the area. and area is a vector quantity. But on the other hand, scalar triple product, it basically represents what? It represents the volume, and it is a scalar quantity, right? Because area is represented by cross product, and scalar triple product is basically the dot product. It's like a dot product but containing three vectors, two vectors sitting like a cross product and one is sitting as a dot of that. In general, area is also a scalar quantity, but as plane is always represented by the normal to it, as we look at the in the mathematics books, that the plane is always characterized by the normal to the plane. So that's why we will take it as a vector quantity, but otherwise this is like a scalar, but we preferably to choose it like a scalar quantity. So this is a vector product and this is a scalar product. And if I try to look at the scale, look at this what we call volume element in the Cartesian coordinate system. So how do we have a look? How do we see that? Suppose there is a coordinate system and say it is x direction, it is x-axis, it is y-axis, and say it is z-axis. Say now we are again having the two vectors. One vector is represented by this and another vector is represented by this. Just a minute. One vector is represented by like this and another vector is also represented by like this. So this is r vector and say this is r plus delta r vector, or in other words I can say that this is a delta r vector. So now this r is represented by x, y and z, and this r plus delta r is represented by, let us call it as r2 vector and say it is a r1 vector. So it is represented by x plus delta x and the y plus delta y and z plus delta z. How? Say let us draw a line perpendicular to x-axis. So and say another line is perpendicular to y-axis and another line is perpendicular to z-axis. Similarly, I have to draw these lines. So that means say I moved delta x distance from here to here, and then along y-axis I moved like this, then I reach at this point, this is 1, and similarly let me finish it. So this is a small element. So what is this? This distance is delta x, this distance is delta y, and this distance is this distance is basically delta z, is from here to here. This is delta x, this is delta y, and this is delta z. So that means this is made up of delta x, which is along I cap, this volume element, small element, and means its three vectors are delta y is along j and delta z is along k. So if I try to find it out, means the volume element, say it is delta v is the small volume element, so it is delta x I cap, its dot product with delta y j cap with the cross product of this, like this. So j cross k is always I. So delta x I cap as it is, and delta y delta z, and it is I cap. because j cross k is I cap. So that means this will become delta x, delta y, delta z, and I dot I is always 1. So that's why it is written as delta x, delta y, and delta z. So therefore, volume element, small volume element is written by delta x, delta y, and the delta z. But if, because we have to take sometimes infinitely small volume, so for that we have to approach delta x approaches to 0, delta y approaches to 0, delta z approaches to 0. Therefore this will become dv, and we can write down it as a dx, dy, and the dz. So this is a way that how we look at the small area and the volume element. So a small area element, we can take help of the cross product, and for the small volume element we have to take the help of that is scalar triple product. So we have used the idea of the scalar triple product. So that's all for today, and in the next lecture I will talk about polar coordinates and the spherical polar coordinates, and try to find out the area and the volume elements in terms of spherical, polar, and the plane polar coordinates. So that's all for this lecture.